Outcome 9 is on demonstrating understanding of solving quadratic equations. So for Foundations 20, we're looking at quadratic equations in the vertex form. So that's this form right here, y equals a times x minus p squared plus q. And your level 2 would be if you can determine who a, p, and q are, the coordinates of the vertex, the equation of the axis of symmetry, the max, the min value, if it opens up or down, and the domain and range. It is a level 3 if you can write the equation of the function given the graph, if you can identify the roots or the zeros or the x-intercepts, so those words all mean the same thing, if you can determine who the y-intercept is, if you can sketch a graph of a quadratic function, and determine the axis of symmetry given the x-intercepts. Your level 4 is if you're able to explain the relationship between the roots, zeros, and x-intercepts, explain what domain and range means in a situation, explain the number of possible x-intercepts a quadratic function has, and explain the effects of the graph when a, p, and q are changed, and being able to solve those situational questions. So here is a quick review. From Math 10, do you remember how to tell which of the following are functions? So if you recall, there was what's called a vertical line test. And what that was is you just had to draw your vertical lines and see how many times you went through the graph. If you only went through once, it's a function. So 1 is a function, 2 is a function, 3, I go through once, twice, not a function. So functions are a relation where each x value is paired with only one y value. So linear functions is what we took in Math 10, and you learned about the slope-intercept form and that standard form, and that would graph a straight line. And in quadratic functions, we see the vertex graphing and the standard form, and we're going to work with the vertex graphing. And the graph makes what's called a parabola. Also, one thing, just with my slides in PowerPoint, the formatting will put this 2 as a large 2 when it should be raised. So it should be an exponent or power. So this guy 2. All right. So defining quadratic functions, it's a relation of the second degree that can be written in the standard form, where y equals ax squared plus bx plus c, where the a cannot be 0. So for example, y equals 4x squared plus 2x plus 1, that would be a quadratic relation. Or if it was in vertex graphing form, we have y equals a times x minus p to the exponent of 2 plus q, where once again that a cannot be 0. So we absolutely have to have a degree of 2. That means anything raised to that exponent of 2. So here it is, and in the vertex form, here it is. So which of the following represents a quadratic function? So remember, we need to be in a degree of 2. So this first one, yep, degree of 2. In B, nope, degree of 1. So this x is not squared, it's not a quadratic function. C is, we have x squared minus 6x, that's all good. D is not, cannot have the x cubed. In E, yep, we have x squared. F, no, because of the x cubed. G is, and H is. All right, so quadratic functions may come in that following form, which we call the vertex form. So this is important. And remembering and being able to identify who the a, p, and q values are is important. So we're going to go through these following 3 examples and figure out who our a value, our p value is, and our q value. Now the only thing that we need to remember is in the following vertex form, notice that they put p as x subtract p. So that p-value, whatever it is in your example, we need to put the opposite. So as I go through number 1, our a value comes first. It's out in front. It's 2. Our p-value is inside the bracket, so here it is, and we have to write the opposite. So it's that positive 4. Q value is on the outside. And we already learned about linear inequalities. That number on the outside, that's your constant. All right, so in the following example, we have a number out in front. That's our a value, -2. Now notice our x, that's raised to x1 of 2. There's nothing else in the brackets. So that p-value is 0. And we have our constant, 15. In example 3, there's nothing out in front, but our a value is multiplying that x squared. So I can't just put 0, because 0 times anything is 0. This one is a 1. It's our spot holder. There would be a 1 here. But inside the brackets, with x, there's nothing there. So I'm not adding or subtracting anything. That's a 0. And our q value, our constant, there's nothing being added or subtracted on. That's a 0. But as for the number out in front of our x squared, it has to be a 1 because they're multiplying. And if it was 0, it would be gone. So let's look at the characteristics of quadratic functions. In class, I'm going to give you a paper with a bunch of graphs, and it's going to show you what happens when we alter the a value or the p value or the q value to see what those values do. Now, just for this slide, and if you're learning online, I'm going to jump to the next slide, and it tells you the a value, that number out in front. If it's a positive, the graph faces up. So here's my graph opening up. If it's a negative, it opens down. If it's 1, it's a normal for width. And if it's greater than 1, the graph's going to be very wide, or sorry, very narrow. Let's look at the next one. Our graph will be very narrow if our value is larger than 1. And if it's a decimal between 0 and 1, it's going to be very wide. Our p-value, if it is a negative p, that means we move right by that many spaces. And if it's a positive, it moves left by that many spaces. So p tells us if I move left or right. Our q value is whether we move up or down. So q value means we move the whole graph down that many spaces, and our positive q value means that's how many we move it up. So I want you to do practice 1, all of the questions, practice 2, numbers 1 to 8.